AI is kind of an interesting term, and what the definition that I heard recently that I thought was interesting was AI is anything that's like a few years away from where we are now, like maybe 5 years away. So right now, this is a conference focused on machine learning applications with deep learning, especially, although not everything is deep learning, but whether it actually constitutes AI, like what people are presenting right now, is debatable. A lot of people would say it's really just kind of an implied machine learning model, and those have been around for a while. The difference is that the machine learning models are much more sophisticated now and tend to be more accurate and better able to solve problems that before were intractable. So I would find it a little bit of a stretch to, for example, say that what I'm working on right now is AI, since it seems, when you get into the code, a little bit more mundane than that, and that AI seems like it's maybe a few years away. But once we get a few years from now, we'll have much more sophisticated models, I'm sure, that are more accurate and able to perform in different situations. And at that point, we might again say AI is a few years away from where we are now. And really, we're working on more sophisticated machine learning right now. But sort of more broadly, I would say AI is a technology that can perhaps reason on its own autonomously without human intervention, maybe after a training phase, and then also it can sort of interact with a human in a way that suggests some sort of high-level reasoning and empathy, for example, which I think we're pretty far from with our algorithms right now. So the point at which we're able to say that what we're working on right now, or a product that we've deployed, is really AI, I think is still maybe a decade or so away before we can hit those milestones. And so I can talk about what I'm working on right now. So I'm working at Arterys, or we have a team that's working on machine learning models to automate certain aspects of radiology post-processing, that is when the radiologists review the studies as opposed to when they're required, that can speed up the radiologist's workflow. So for example, at Arterys, we make a post-processing software suite that's cloud-based and is used for post-processing of cardiac MRI. So that's MRIs done of the heart. And one component of that post-processing is to contour the ventricles of the heart, which is typically done, or in the past has been done manually, in order to get an estimate of the volumes of the ventricles. And by getting the volumes, you can estimate the volume at maximum dilation and maximum contraction, and you use that to determine how much blood is pumped out of the heart with each cardiac cycle, and therefore determine whether the patient has heart failure, which is defined in those measurement terms as when the patient is not pumping out enough blood with each cardiac cycle to meet the body's needs. And so traditionally, this process of doing the contouring has required a lot of manual effort and manually drawing, or maybe using semi-automated tools that require a lot of correction. And so what we bring to the table is a deep learning-based system that has been trained on thousands of clinically annotated studies and can now do that contouring automatically. So the component of the workflow that used to take 30 or 60 minutes is now not quite completely free because the radiologist has to check it, but is down an order of magnitude from where it used to be. So it's really kind of an automation tool, and to me, I have seen fundamentally what it consists of, and it's really a machine learning application. I wouldn't really call it AI, but to an observer who just sees that sort of they upload a study and magically something that used to take an hour has been completed for them, they might perceive that as AI because it has done something that previously took some intellectual effort of theirs automatically. I can speak to my field, which is medical, and there's an interesting differentiation between, for example, autonomous vehicles and medicine and AI in both those fields. And one interesting thing is the population that is potentially at risk for being displaced by those technologies. And the radiologist is that population for medicine. And we don't say that we intend to replace the radiologist. We want to work with the radiologist and enhance their workflow and make it simpler. Autonomous vehicles, maybe they're marketing tools, not to say they're going to replace, for example, taxi drivers. But certainly for both of these fields, you can sort of connect the dots and see that might be, if not tomorrow, then maybe 10 years down the road, that could be the scenario. So one thing that we're very careful about in our current work is emphasizing that our goal right now is not to replace the radiologist. Our goal is to help the radiologist, and especially to help the radiologist perform the tasks that take them a long time right now and are really not intellectually stimulating at all. So for example, this process of contouring the ventricles of the heart, Without a visual aid, it's maybe a little bit hard to figure out what that means, but essentially you see sort of a bright region and a dark region, and it's drawing the line between the bright and the dark region over and over again on many different slices at different time points, on different structures of the heart, and the task is basically always the same, and it's a boring task, honestly, that radiologists don't want to do. So the way we're successful is by emphasizing that we're not replacing the radiologist, we're replacing this task that you hate doing. And by doing so, we are speeding up your workflow and making the workflow sort of more pleasant to do, because you can spend more time on the more intellectually stimulating activities such as diagnosing kind of confusing cases or complex cases and working on piecing together this information to make a diagnosis. So at least in the medical field, I think AI is going to be really successful when we are helping doctors and complementing the work they do and removing components that they don't want to do. And it's going to be much less successful, at least in the near term, for things like automating diagnosis, where you're sort of claiming, I can do what the doctor does better, we don't need the doctor anymore. And we don't want to go in that direction as a company right now, and I think that's going to be less successful because in the end, we're selling to doctors and to hospitals, and you can't sell to somebody something that you say is going to replace them. So for that and other reasons, I think taking the doctor's full job is not going to be successful, but automating the boring parts of the job will be. And I think probably, my field is the medical field, and I don't know as much about other fields, but I think that trend will probably be true for a long time in other fields as well.
Keep you up at night?
Sure. So I would say, again, the key focus is in automating the components of radiology that are tedious, boring, and what I didn't mention before is also those that have a lot of inter-rater variation. So for example, segmenting the ventricles of the heart, even though it's kind of a straightforward task, different people do it different ways, and as a result there's a lot of inter-rater variation. You make a different diagnosis depending on which physician is annotating your study. So one advantage we bring is that by automating it, there's a very consistent way of doing the segmentation, and you don't have this variation with different clinicians. But in terms of, maybe I missed the first part of the question. It was, remind me the question one more time.
And then,
key focus.
What keeps you up? So like, what's like a problem
Okay.
that means a lot to you?
Okay, so the key focus again is automating the tedious parts of radiology that the clinicians don't want to do. What keeps me up at night is something that the FDA and I'm sure other regulatory bodies in other fields are working to minimize, but it's the possibility that a patient will be scanned, for example, again for like the cardiac segmentation thing, where the patient is extremely different from any patient we've trained the model on or tested the model on. And it's not possible to test or validate your model on every possible patient, scan with every possible scanner and so on. So this is going to happen. And the worry is that clinicians, because our model works so well and so much of the time, for example, they may become complacent and sort of assume that it always works and sort of stop double checking the model. And then in this scenario where it does not work as well, because it's a very uncommon case, they will miss that opportunity to double check the model. So I think we really need a way, without being heavy-handed about it, to encourage the clinicians to double check their work, the work of the model, and make sure that they're always really in the loop, both sort of literally because they have to click the button to accept it, but also in the spirit of being in the loop, where they really are cognitively involved in validating the model's results. And sort of the example of where that can go tragically wrong is the Tesla incident where the Tesla autopilot was involved in an accident. And the reason is that the driver became totally complacent, because 99% of the time it had always worked either perfectly or well enough, so they became complacent and assumed that it would work 100% of the time. And we need to avoid that both in autonomous vehicles and in medicine, and really in any scenario where there's our lives at risk or human safety is at risk. I thought that a really nice thing about this conference, which is not really as much of an academic conference, but is more of an overview of industry, is sort of the diversity of the different presentations. So We've had presentations on natural language processing and visual question answering, on synthesizing music, for example, using AI, on how to manage distributed systems that are performing inference with deep learning models and so on. And I think that diversity of applications that are relevant to different degrees, but at least always interesting to what we're working on as a commercial company is really interesting and helpful. And unfortunately, I do have a flight to catch tonight, so I won't be attending the rest of the week, but I'd be looking forward to more of the same upcoming in the rest of the week. Okay, great.